Good morning students, how are you? Hope you are all in the pink of health. I am Atunurai and you are watching Bond Making and Bond Breaking channel. On the part 6 video, I have discussed about the introduction of carboxylic acid and the UPAC nomenclature. Today, I am going to discuss with you on the preparation method of carboxylic acids. So, with optimistic energy, we have to start the new topic. Firstly, preparation of carboxylic acid. Now, the first is oxidation method. First is oxidation method. Oxidation method. So, what is the oxidation method? Oxidation method means if you have alcohol. How is it alcohol? Because the presence of OH group. This is alcohol. So you have alcohol and you want to oxidize it by the oxidizing reagent, that is K2Cr2, K2Cr2O7 and H2SO4. What will you get? You get, that is RCHO, that is aldehyde. And then if you again oxidize it, you get RCOOH, that is acid. So on the first oxidizing, you get aldehyde from the alcohol, then you again oxidize the aldehyde and you get acid. So this is a general and simple and important method that is called oxidation method. Okay, now where is my duster? Okay, so the second one is, if this is 1 degree alcohol, from 2 degree alcohol, if you have CH3, CHOH and CH3, this is 2 degree alcohol and you want to use oxidizing reagent. Okay, so good oxidizing reagent, K2Cr2O7 is a very good oxidizing reagent. So you use K2Cr2O7 and H2SO4, that is concentrated H2SO4. So you get the product, you just break this bond, so you get CH3 COOH and then HCOOH. Okay, this group gives you HCOOH and that is CH3COOH. Now take another example. If you take CH3CH2 CHOH CH3 1 2 3 CH2 CH3 1 2 3 4 5, that is 1 2 3 pentan 3 all. So you get pentan 3 all, 1 2 3 4 5. So pent, the bond between them single, so pentan, the position of OH 3, so 3 OH is called all, so pentan 3 all. Okay, so as you have pentan 3 all, you use K2Cr2O7 and H2SO4, which is a good oxidizing reagent. Then you get this product, that is CH3 CH2, this is CH3 CH2 and it gives you COOH. Okay, and this is CH3 COOH, CH3 COOH. So it gives you CH3COOH and CH3CH2COOH. Hope you understand. This is CH3CH2, CH3CH2, and this group gives you COOH. So this is COOH, and this is CH3. One CH2 is removed. One carbon should be reduced. So this carbon gives you COOH. Okay, so one hydrogen should be reduced. Okay, not carbon, hydrogen. So it gives you COH. Now take another example. Now take another examples. If you have this, now this is C and OH, CHOH. So 1, 2, 3, 4, and then something CH3. You take this and you want to react with an oxidizing reagent, that is K2Cr2O7, and that is potassium dichromate, K2Cr2O7 and H2SO4. Okay, very simple. We take any compounds of alcohol, then you oxidize it with K2Cr2O7 and H2SO4. So simply you break this bond. So you get this group benzene, and I say that this carbon gives you COH. So this is COH, and this CH3 gives you HCOH. So those are the products. Okay. Now, okay, clear? So those are the second degree alcohol. Okay. Now, oxidation of methyl ketones. So the third one is oxidation of methyl ketone. Oxidation of methyl ketones. Okay. So oxidation of methyl ketones, for this reaction I take an example of CH3 CH2 CH2 COH. I take this COH. Okay. From here you just take HCl. HCl. So you get, firstly I take this group COCH3. Okay. Then you use NaOH and I2. NaOH and I2. What will be the product? The product is CH3 CH2 CH2 COONA, and then you get CHI3. Then you acidify it with the presence of HCl. When you acidify it, Na and Cl is removed from here, so you get H plus from this position. So you get CH3 CH2 CH2 CH3 CH2 CH2 C. Na and Cl makes a compound NaCl, and then you get COO, that is from minus and it is plus, so minus and plus attract with each other, so you get this compound COH. So this is the oxidation of the methyl ketone. Okay. Now take another examples of oxidation of methyl ketone. If you take this compound, this is carbonyl compound of ketone compound CO, methyl ketone. This is called methyl ketone. Okay, this is methyl ketone, and you want to react with NaOH and I2 as well as I2. So if you react with NaOH and I2, you get the product. That product is C and acidification. First step and second step. We write two steps in one way. So you get benzoic acid. Hope you understand. Okay. You take this methyl ketone and you react with NaOH and I2. NaOH and I2. Okay, NaOH and I2, and then the second step is you take acidification step. So after acidification, you get this product CH3COOH. This is the oxidation of methyl ketone. Now the third preparation process is oxidation of alkyl benzene. Oxidation of alkyl benzene. Number 3, oxidation of alkyl benzene. Oxidation of alkyl benzene. Okay, so third reaction is oxidation of alkyl benzene. So for alkyl benzene, you take toluene. Okay, this is the alkyl benzene. Why this is alkyl benzene? This is methane. This is methane. CH4 is methane. If you remove one hydrogen from here, this group is called alkyl group. Then you used this phenyl C6H5 here. So you get this C6H5. This is C6H5 and then CH3. So this is called alkyl. This group is called alkyl and this is benzene. So alkyl benzene. Then you oxidized it. So you have good oxidizing reagent, that is K2Cr2O7 and H2SO4. As you have K2Cr2O7 and H2SO4, from toluene you get COOH, that is COOH. This is the oxidation of alkyl benzene. Okay, this is the oxidation of alkyl benzene. You can also take German oxygen. So oxidation of alkyl benzene means you have toluene. Then you use K2Cr2O7, that is potassium dichromate, and H2SO4. Then you use German oxygen. So after using this reagent, you get benzoic acid. Simple, na? You have toluene. You use just a good oxidizing agent, that is K2Cr2O7 and H2SO4. Then you can use German oxygen. So from this you can get this benzoic acid. So this is called benzoic acid and this is toluene. So this is a preparation method from toluene to benzoic acid through the oxidation of alkyl benzene. Okay. So the next one, fourth one is, so I take more examples. If you take this, CH2CH3, then you use K2Cr2O7, H2SO4 and German oxygen. Though the chain of carbon is increasing, but the product will be same. That is COOH. The main product is benzoic acid. Okay. If you take 2 degree, this is 1 degree. So if you take 2 degree, that means if you take this CH3 whole 2. Okay. That means if you utilize K2Cr2O7 and H2SO4 with the help of German oxygen, you get this same product. You get this same product. Okay, but if you take third group, so CH3 whole 3. If you take this tertiary group, then you want to react with K2Cr2O7 and H2SO4 with the help of German oxygen. So you don't get any product. Okay, so firstly I give you this product, that is CH2CH3. Then I take this K2Cr2O7 and H2SO4 with German oxygen. Okay, German oxygen. So you get this benzoic acid. Just think about it. You take primary groups, you oxidize it, you get COH. You take this secondary group, you use K2Cr2O7 H2SO4 as an oxidizing agent, you get benzoic acid. But when you use third group, and you give this oxidizing reagent, but the product is not given. So for third group you cannot get this product. That should be remembered. That's the key point of this reaction. Third group does not react on it. Okay. Now the fourth method is hydrolysis of alkyl cyanide. So as you have, so what I say, from alkyl or alkyl for alkyl cyanide, from alkyl cyanide. So I give you the simple process. If you have CH3CN, this is cyanide compound, so you have CH3CN. Then if you use it, okay, as you have, if you use it H2O and dilute NaOH, and you have also a heat. So the product is COONA, that is CH3COONA. So the product is CH3COONA. Then you acidify it with the acid. It gives you H plus. So Na plus is removed from here, and this is minus and this is plus, H plus. So CH3CO minus react with this H plus. So you get the product acetic acid, that is CH3COOH. Very simple. Or I have another process, that is CH3Cl. You have this group, then you convert it by the Stephen method. That is SnCl2 and HCl. Stephen method, you use SnCl2 and HCl, you get CH3CHO. So you can prepare CH3CHO, then oxidize it. So if you oxidize it, you get CH3COOH. This is also a good method to prepare from cyanide to acid. So you have two ways, not only two ways, you can apply any ways from where you get CN2COH. That should be appropriate. That ways should be appropriate. So you have cyanide group, you use dilute NaOH and H2O, you get the CONA, and Na, after you get Na, you use H plus for acidification. After this acidification, you get this acetic group. Or the second process is, if you have cyanide group, you have already learned about the aldehyde, how to prepare aldehyde from alkyl nitrite. So you use a Stephen reaction, so cyanide converted into aldehyde. Then you use oxidation method and you get the acid. So those are the very simple ways from where you can prepare alkyl cyanide to acid. Now from Grignard. So next is from Grignard. From Grignard, I give you CH3 MgBr. This is the organometallic compound CH3 MgBr, and you take this group. So this is delta positive and this is delta negative. As it is delta negative, it hit this carbon and this bond is broken. So the product will be, this is CH3 from this carbon is joined. This is double bond O and this is O minus. So CH3CO, then you acidified it. So you get H plus, negative always attracted with H positive. So CH3COOH. So the product is CH3COOH. This is a simple process from to preparation acid from Grignard reagent. Okay. So the next is hydrolysis of ester. So the next is hydrolysis of ester. So the next is hydrolysis of ester. Okay, hydrolysis of ester. So hydrolysis of ester means if you have this ester group CH3 COOC2H5, you have this group, then it react with two ways. One is if you use HCl and reflux it, or if you have NaOH and reflux it. So one on the reflux it. So you reflux it through acid, and another process is you reflux with base. What will be the product? The product is from for acid you get this product CH3COH, and the side product is COH, and the side product is C2H5OH. So the side product is C2H5OH, alcohol and acid. Okay, but for this reason, for this case, for NaOH you get two product, that is CH3 that is C2H5OH and CH3COONA. CH3COONA firstly. For Na you get CH3COONA and C2H5 reacts with this OH. So you get C2H5OH. After this you acidified it. CH3COONA you acidified it and you get CH3COOH, and this product is constant, so C2H5OH. You take ester firstly, then you acidified it, acidification by reflection, then you get acid and alcohol. But if you use a strong base, that is NaOH, sodium hydroxide, you get COONA. So firstly you should acidify it. After acidification you get CH3COOH. This is a simple method. Okay, so this is called hydrolysis of ester through acid through base. Next one, if you have acyl chloride, so the next process is from acyl halide or acyl chloride. From acyl from acyl halide. From acyl halide, that is from acyl halide. So from acyl halide, you take a acyl group, that is RCOCl, and you want to prepare COOH. So if you have this, you just acidify it. Okay, so H2O gives you H plus and OH minus, and H plus and Cl minus is removed from here, so the product is RCO and OH. That is simple method. Okay, but if you have this group CH3CO whole to CO whole to O, you take this group. So if you add water with excess amount, you get 2 CH3, 2 amount of CH3CO. This is not that from acyl chloride. Okay, so from acyl halide, how can you prepare? You just hydrolyze it by using H2O. If you have H2O, it gives you H plus and OH minus. And we know that H plus always wants to react with Cl. So H plus react with Cl minus. So H plus and Cl minus from H. And water always gives you H plus and OH minus. So OH minus, what will be the product? The product is OH minus, and there is RCO plus. So this plus react with OH minus and give the product acid. So this is the simple method to prepare from acyl halide. Okay. Now the next method. Now the next method is carboxylation of alkene. Okay, carboxylation of alkene. Carboxylation of alkene. So you take alkene. You take this alkene. Alkene means carbon and carbon should have double bond. This is alkene. Then you use CO. Okay, you react with CO and H2O with the help of acid, that is H3PO4. H3PO4. You should use temperature and pressure. Temperature will be 300 to 400 centigrade, and you should write pressure. As you don't know the accurate pressure, you just write the pressure. If you use it, you get the product CH3 CH2 COOH. That will be the product. CH3, if this bond is broken, CH3 COOH. CH3 CH2 COOH. So the product is that. This is the carboxylation of alkane. So this is the carboxylation of alkane. So this is very simple. Okay. If you have, now we take another example. If you have this group CH3, this is CH3 bond, CH double bond, CH2. If you have this, then you want to react with carbon monoxide and water with the help of H3PO4 and with 300 to 400 degrees centigrade as well as pressure. Here the product will be CH3 CH2 CH2COOH. That will be the product, should be, but it's not. That will be product should be according to the previous method, so it does not follow it. What will be the product? The product is CH3CH3, okay, and then COOH. That will be the product. That will be the product. If you think so, that this match with the previous way, this is not. You get from here this product. So this is the carboxylation of alkene. Okay. So the next and last preparation method of from malonic acid. Okay, malonic acid. So from malonic acid. So you take for malonic acid CH2 whole 2. So I take this malonic group, and this malonic reacts on temperature. Temperature may be 150 degree to 200 degree centigrade. 200, okay. So this group is react with temperature and you get acid. You get acid as well as the carbon dioxide. If you have malonic acid, okay, if you have malonic acid and you heated it, so the product will be the acetic acid. So malonic acid after heating gives you the acetic acid and as well as the carbon dioxide, because it is the natural phenomena. Entropy helps to carbon dioxide to remove from this reaction by using heat. Okay, so those are the preparation method of carboxylic acids. So those are the very important methods. It helps you on coming NEET exam as well as the joint entrance exam and obviously for the board exam. So keep studying, take care of your health. Thank you so much for watching my video and wait for my next video.